Solve the equation. Identify any extraneous solutions. We have the square root of 2x plus 1 minus the square root of x plus 1 equals 2. Our first step will be to isolate one of the radicals, so I'm going to leave the square root of 2x plus 1 on the left-hand side of our equation. I'm going to grab this term, negative square root of x plus 1, I'm going to move it to the right-hand side, or I'm going to simply add this term to both sides of the equation, giving us 2 plus the square root of x plus 1. So you want to isolate one of your radicals, and I chose to isolate the first radical. Now we're going to square both sides of our equation. Square the left side and square the whole right side of our equation. The left side is pretty basic. The left side of the equation, the square and the square root negate each other, and we are left with 2x plus 1. However, the right-hand side, we're going to be squaring a binomial, so we're going to have a complicated, at first it's going to look complicated expression on the right-hand side. So go ahead and square the first term. Remember the shortcut for squaring a binomial. We're going to square the first term, 2 squared, and get 4. We're going to multiply the 2 together and double it. So 2 times positive square root of x plus 1 is 2 root x plus 1, and we're going to double that and get positive 4 square root of x plus 1. And then finally we're going to square the last term, and again when we square the square root of x plus 1 we simply get positive x plus 1. So you can see we've taken the original equation that contained 2 radicals, and we now have an equation that only contains 1 radical. So our next job will be to get this term with the radical in it all by itself. But we got some like terms here that we can clean up here a little bit. So we have 2x plus 1 equals 4 plus 1, 5, plus x, plus the radical, or the term plus 4 times the square root of x plus 1. So again, we want to get the radical isolated, this term isolated. So we're going to subtract 5 from both sides and also subtract x from both sides. Subtracting x from both sides, 2x minus x gives us x, and positive 1 minus 5 is a negative 4. So now we have that equal to 4 times the radical x plus 1. So again, we want to get this radical by. Now, you do have the option here of dividing both sides by 4. However, I would advise against that only because it's going to create fractions over here on the left-hand side. So let's just go ahead and square both sides of our equation the way that it sits right now. So we'll square the whole left side again, and we'll square the whole right side again. On the left-hand side, again, we're squaring a binomial, and when we square x minus 4, we get x squared minus 8x plus 16. And on the right-hand side, when we square this expression, we square the 4 and we square the square root of x plus 1. So squaring 4 gives us 16. Squaring the square root of x plus 1 gives us the quantity x plus 1. On the right-hand side, we can use the distributive property. So we'll have x squared minus 8x plus 16 equals 16x plus 16. And now we'll go ahead and get our equation equal to 0 because I see I have a quadratic equation. So I'll leave the x squared term where it's at. Subtract 16x from both sides, giving us negative 24x. And I'm going to subtract 16 from both sides, so the 16s eliminate each other, and we have this equal to 0. We'll solve our quadratic by factoring. Factor out an x. We're left with x minus 24 equals 0. We set each factor equal to 0. X could either equal 0 or x minus 24 equals 0, giving us our other possible solution of positive 24. So currently we have 2 possible solutions, 0 or positive 24, and we need to check our solutions by substituting them into the original problem. So let's check out 0 first. When we go up to the original problem, 2 times 0 is 0. 0 plus 1 is 1, and the square root of 1 is 1. Again, letting x be 0. 0 plus 1 is 1, and the square root of 1 is 1. However, 1 minus 1 does not equal 2. So 0 does not work. 0 is an extraneous solution, so it is out. Now we must test 24. Substituting 24. 2 times 24 is 48. 48 plus 1 is 49, and the square root of 49 is 7. Again, letting x be 24. 24 plus 1 is 25. Square root of 25 is 5, and 7 minus 5 does equal 2. So x equals 24 is our only solution.